Good afternoon, class. In today's video, what I wanted to do was to cover an example problem from Circuits Part 2, and so this one will cover number 6. However, I didn't want to just, this is number 6 in the problem set. However, what I didn't want to do was use two example problems because there are two types of these problems within this within this homework set. The reason I didn't do I wanted to show the same problem but in two different ways was I thought it'd be a little bit more instructive if all of the different numbers that would be used to label the circuits or all the resistors in the circuit were not present and it was just the same numbers. I just want to get the point across that changing something in the description of the problem actually does matter, and there are things to watch out for because they do change the math and they do change how you approach the actual problem itself. So with that, I thought I'd do number 6, which is a series of circuits. R1 is 1, R2 is 2, R3 is 3, and R4 is 4. It's a combination circuit, so R1 and R2 are connected in series, R3 and R4 are connected in parallel, and all of them are connected in parallel. This one is number 6. What I decided to do in the second part of this problem is to change one word, and one word only, and that is they're all connected in series, not parallel. And that completely changes the picture. So first thing I thought I'd do was, instead of showing equations in like I usually do in blue, I thought I'd draw out the circuit diagram. That way you're able to see, okay, this is what it would look like, and this is how different it would look. And of course, all of the work is done in red over here, so that way you can kind of tell, okay, this is all the work. So here we go. Start with our battery, our voltage source. I didn't label this as any voltage because I just wanted to know what I just wanted to show the voltage source, just to show a complete circuit. Now, so I've got series, R1 and R2 are connected in series. They have to be in series. R3 and R4 are in parallel and they're connected together just like they normally would. But because they're all connected in parallel, I had to put R1 and R2 on the same loop as with each other, and because they're all connected in parallel, R3 and R4, which are two different loops, they're going to have to connect with the loop that is R1 plus R2, the ones that are connected in series. So because of that, what I'm going to do now is I'm going to actually just write out what the combination of all of those resistances looks like to get our combo circuit resistance. And of course they're all in parallel, so I have to deal with all of these things as if they're as if each of them are, or I should put it this way, instead of all of them being 4 resistors in this series, there's actually only 3 of them. The first one is the combination of R1 and R2, so I can actually treat that as one circuit, which I added up in series. Now, to do that, I made sure to keep everything in the parentheses over here. That's why, as you can see, R1 plus R2 is in parentheses in the numerator because it's being multiplied. But in the second one, it's also in parentheses just to show that what I'm trying to do is just to show that R1 and R2 are going to be combined in series, and that's why I've put them together. And just to show that they're together in that regard. So here we go. R1 plus R2 is going to be our first element. Our second element is R3. Our third element is R4. So we put this one and multiply all our elements together, and then we add all our elements together. So, which is nice. 1 plus 2 is 3. 3 times 3 times 4 is going to be 36, which is 9 times 4. And then, of course, 3 plus 3 plus 4 is 10. So we get a nice number of 36 over 10. Of course, we have to simplify. So don't forget to do that. Of course, some of you might say, oh, but Mister, isn't that 3.6? I can easily change that to a decimal in my head. And the answer is yes. And if you put that on the test as your answer is 3.6, that's totally fine because it's a terminating decimal, and I am okay with that. However, to keep just keep on the track of keeping on the same track of, I want to keep this all fractions, I want to be consistent in this, what I'm going to do is I'm going to say, okay, I'm going to simplify 36 over 10 to 18 over 5 ohms, and we'll call that good. That's the total resistance of the circuit. Now let's see what happens if we change just that one word. Instead of it being all of them connected in parallel, all of them will be connected in series. This dramatically changes the picture that we draw. So we've got our voltage source, R1 and R2 are now connected in series like they were before. R3 and R4 are still connected in parallel, but all of these elements are in basically one loop. Even though R3 and R4 are technically in their own loops, when we add them together, they will become one element, just one single element that we will put together, we will add up with R1 and R2. So that's what's reflected in the work that we've done over here. So the total resistance is going to be R1 plus R2 plus our combination of parallel elements. So that, I guess you could call it like some other, the sum of the parallel, or the series plus the parallel parts, and the parallel parts have to be added in parallel like we've done before. So we have to use what we did from the last video on how to add things together, how to add circuits, resistors together in parallel to get our number here. So our total will be 1 plus 2 plus 12 over 7, because 3 times 4 is 12, 3 plus 4 is 7. So we look at that and say, okay, well, I can combine this whole number with this fraction, because 3 is also 21 over 7. So 21 plus 12 is 33. And so our answer will be 33 over 7 ohms. And as you can clearly see, this one word from parallel to series has changed it from 18 over 5, very nice, fairly nice, terminating decimal resistance, to a pretty crazy 33 over 7 ohms. So the wording of the problem makes a difference. You should definitely, whenever you're looking at any of these problems in the set, plus the other two homework sets, parts 3 and 4, you should also check that out. They're all connected. How are they connected? In series or in parallel? And then, of course, which ones are connected in series? Which ones are connected in parallel? Hopefully you do it this way, so that it will, you get an idea of which, you can see, okay, these are connected in series, these are connected in parallel. That way you can at least say, okay, here we go. I can make this, I can kind of make this work. So I wanted to show that as an example, and so hopefully that will help you in not just part 2 of the circuit problems, but also parts 3 and 4. So that concludes this example problem. Good luck in your studies. May the force be with you.